Welcome everyone to the first ever online hackathon, DEVrupt Hospitality.
Welcome everybody. I'm Alex, head of engineering at Limehome.
I'm Vasily. I'm software engineer and co-founder of Apaleo. The goal of this event is to invite developers around the world to join our community and discover the whole new world of challenging projects and problems to solve. This event starts today, 1st of March, and goes for 1 month until 1st of April. And it's proudly sponsored by our partners at Adyen, JetBrains, and Pact. Let me introduce you to the timeline that we have here. So first, of course, you need to sign up for this hackathon, join our Slack, where you can then team up, find other participants, brainstorm your idea. You can also get help from our advisors in the general channel. And then once you did all of this and you're all set, you can just hack, develop, sleep, and repeat it again and again until you are done, and submit your project until 31st of March. And by submitting, I mean just publishing your source code to the GitHub repository, label it with the topic DEVrupt-hospitality, record short demo video, put it into the README, that's it. And when it comes to the prizes, we have pool of 5,000 euro. We have yearly subscriptions to any JetBrains product of choice. We have copies of Node.js design patterns book and more. And of course, everyone who is going to participate, they will get a swag pack, so you have something to remember. Hey, Alex, do you want to explain about the starter kit that we prepared?
Hey, sure. Mainly, we decided to provide to all the participants these two different boilerplate, mainly developed using Node.js and serverless. And I would say it's the easier way to plug and play with the Apaleo API. So I would say that in a couple of minutes, you're able to download the project, initialize it, and run a couple of requests against the API that you will have to use for the hackathon.
Yeah, this is actually cool. I like, so we, as you mentioned, we have two different projects. The difference is that this one is uses serverless framework. So if you would like to use AWS Cloud, Azure, or Google, you can easily deploy it by just running one command. And another one uses the Docker file, so you can build a container and just deploy to any cloud provider of your choice. And it has already an API client built in, so it's easy to get started. Of course, it might be hard to come up with the idea of your project because the hospitality industry is so specific. Therefore, we prepared a list of topics, I would say suggestions that you can go through, pick one that you like, and start brainstorming your app. For example, automation is a good example. You might think how you can automate different business flows, or if there is something that we didn't think about, it's always welcome, and you can come up with your own idea of your own topic. And Alex, what's your favorite topic?
Yes, one favorite topic, also some of the challenges that we currently have at Limehome is guest identification. We do have online check-ins, and so you can imagine that for us, identify the guest that is staying at our property is key. And I would really enjoy to see what the agility of an hackathon will give to us in terms of really great idea around this use case.
I agree, especially right now with the current situation, identifying guests and automating this. And of course, we have judges who are going to judge your projects. We have Julien from Adyen, we have Stefan from Apaleo, Alex, you already know, and we have Luciano. And they're going to judge your projects a week after the hackathon is over. And based on the several criteria listed here, they will give a score and we will pick 3 winners. We'll also put the FAQ section for you with the answers for the questions that you might have. And this hackathon is hosted by Apaleo and Limehome. And right now you might ask, okay, what is Apaleo and what is a Limehome? And Alex, I don't know how we come up with this idea of the hackathon, but this is the first time when we do something like this.
Yeah, we mainly decided to see what the community can bring us after years of collaboration. We do use a lot Apaleo, and not everybody know that thanks to Apaleo, you're easy.
And also, why do we do hackathon right now, and why something like similar didn't happen before? I think it's the answer would be that there was no place where developers could come over, especially in the hospitality industry, and they're just starting brainstorming and hacking around and developing and coding apps. And that's exactly what we at Apaleo try to do. We are developing the platform, open platform, where everyone is welcomed, especially developers, to come over and be creative and solve challenging problems in the hospitality industry. In fact, our approach is API first. So whatever we do in our platform, we first develop API and then we develop features, and developers love it. If you go, for example, to api.apaleo.com, you will see the Swagger documentation of our APIs with the different modules, and all functionality of our platform is available here at your service. And it's just, you are limited by your imagination what you can do with this. For example, you can request a list of all properties in the chain. If it's a hotel chain, you can see all the properties that are in there, or you can create new one if you want. And same for bookings and reservations. You can get access to reservation data, guest data. You can create reservations. You can do any operations with them, like check-in or check-out or cancel. But this is one side where we have developers developing cool apps on top of Apaleo platform. On another side, we have our customers. It's individual hotels, hotel chains, or other accommodation providers. And when they meet with the developers, this is what makes our platform and ecosystem alive.
Hey, Vasily, I know that you work in the hospitality industry for a few years. Where is the idea of building this developer community coming from?
Well, at Apaleo, we don't believe in all-in-one solutions. We build a platform where we handle basic things like inventory, rates, reservations, and then we have really powerful API open to the public. And that's where developers and our partners are coming to our platform and develop cool applications on top that they extend our product. And this is where Apaleo App Store comes into the place, where our customers go and look for the applications that you develop and make it available. Well, right now in our App Store, we have more than 100 apps, and every customer uses them. And later today, we will show you how you can actually take a real life problem, solve it with the technology, and make it available as application in App Store. But this is not only about applications from the App Store, it's also about enabling our customers to use the API and develop custom apps tailored for them. I know that, Alex, you guys from Limehome take a full advantage of this by just looking at number of API clients you have.
That's true. Because at Limehome, we decided to keep the majority of the technology that we use to operate our properties in-house. So this is one of the main difference comparing Limehome to the traditional hotel operator. And how could we build all the process? How could we cover the traditional processes with a technology trying to roll out something in a short time? We had to find the right partner, and we found Apaleo. Limehome is not really a standard hotel chain. Yeah. We do operate properties, and we try to automate all the traditional process with our technology. So we don't have anyone at the property waiting for you. We cover from the check-in to the checkout to the accounting staff for our guests via digitalization.
Yeah, but I know that also the Limehome is not really like standard hotel chain, right? So it's more like service apartments, and you actually grow very fast. So you onboard new properties, I don't know, almost every week. And I know that your onboarding pipeline is also fully automated, right? So you use, for example, inventory API to create new properties, or you use inventory API to read units, and rate plan API to read rate plans, right?
Yeah, that's true. We have our BI team, business intelligence team, that is looking around Europe for property that can be onboarded in our business model. And after that, we find out if the property can have the right setup or is as the right position. We can easily create and onboard the property in Apaleo using the inventory APIs.
So it's more like, how would you say you are like 50-50 tech company and hospitality company?
This is another question. I would say that we try to give to our guests an high quality and full equipped apartment for a good price. And this also thank you to the technologies that is running behind the prices algorithm.
Yeah. Actually, I tried once this new concept and the online check-in. So actually, I enjoyed it really a lot. I didn't have to interact with anyone, and it happened actually several weeks ago during the Corona time. So this works perfectly fine.
Yeah, that is a perfect use case, Vasily, because also considering the current regulation where a business traveler has to show proof of travel, so you cannot really check in people if they are not providing you the paper from the companies or a proof that they have to travel around. And we could easily integrate an uploading of this file for our customer success agent in this online check-in process.
Yeah,
It's also the plus of having the technology now. You can adapt and you can be fast on shipping out and releasing new features for your guests.
right. By the way, do you guys use application from the App Store, or you only develop your custom apps?
The majority of the use cases that we have using Apaleo are using custom apps. So we build using the APIs, our internal tools. But I assume the same time we do use for same A/B test also applications that are available in your store, like for voucher offer or similar business cases.
Yeah. I think you also do use like Booking.com app for direct Booking.com connection.
True. That is something that I gave for granted to Apaleo, but of course we do push all our properties to OTA like Booking.com, Airbnb, or Expedia using the integration that Apaleo provides us.
Okay. And now let's move on to one of app developers who has their applications in our app store. Please welcome Tim Riemenschneider, software developer from detco.
Hi, my name is Tim from detco, and I want to talk to you about developing apps for Apaleo. So, who are we? We are a full service agency. We founded in 2005. We have offices in Bremen and Hamburg, and currently we have 12 employees. We began with development for the hotel and tourism industry in 2008, and we specialized on individual and customer specific solutions. In 2018, we began with individual solutions based on the Apaleo platform. In 2020, we deployed our first app to the Apaleo store to a greater audience, and currently we have 4 apps in the store with more apps planned or in development. Why is development with Apaleo so easy? Well, when working with hospitality solutions in the past, we had to struggle with monolithic APIs with the complicated usage. Sometimes those APIs were undocumented and they often require on-premise hardware or on-premise software. And maybe there isn't even any API at all. With Apaleo, that is different. There is an open API available at the central location. It is very well documented. Thanks to Swagger, you can try out all API calls directly in the browser to play with them. And this API is also used by Apaleo itself. So if you open the user interface and in the browser and open the developer tools of your browser, you can see the API calls directly in the network tab. The Apaleo API runs over HTTPS, so you don't need any on-premise systems. You can access them anywhere across the internet. I want to show you a use case we developed an app for, the so-called guest mailings app. There was a great demand of hotels wanting to automatically send notifications for bookings, for cancellations, for invoices, and so on. And so we built an app for that. Our app uses Apaleo Connect to be available for a broad audience. That means that the app authenticates using OAuth to the API. Our app has two delivery options. There's first the automatic delivery. That means that the mails are automatically sent whenever a new reservation is made or reservation is modified and so on. But you can also send on-demand mails from the Apaleo backend. That can be used, for example, to send the notifications to different addresses or to include additional comments and so on. Using the app is very easy for the hotel. They only have to select the app from the App Store and do a very small, short configuration to set an reply to address and optionally to upload a logo, and the app is ready to go. In the app there are several APIs from Apaleo we use. There's the integration into the UI, the so-called Apaleo 1, that can be used to seamlessly integrate your app into Apaleo. That is done by iframes, and the app seems to be a part of Apaleo. There is no visible difference for the hotel. Then there are webhooks that can be used to be notified whenever a booking is created or a reservation is changed and so on. And there are the normal API calls, for example, to get reservation details, to format those data into a mail. Our app is deployed on the classic LAMP stack. That means we have a server with an Apache web server, MySQL and PHP, but you can deploy apps to any platform you can imagine. For example, you can use cloud-based solutions like Amazon Web Services, Azure, and so on. And you can use your preferred programming language. You're very free to use any language you want as long as you have a REST client to make the API calls. So I want to show you how that looks. I'm here inside the Apaleo backend, and there is the app integrated into the menu, and we have several types of mails we can send: booking confirmation for new reservations, modifications when the reservation is changed, cancellations, and invoice mails, which means that we can send the invoice as a PDF attachment by mail. We currently support 3 languages, German, English, and French, but my test hotel here only uses German and English, so French is not shown here, but this is supported as well. Well, let's make a new reservation. I speed that up a bit by copying already present reservation. So I make this reservation. So now a new reservation is made in Apaleo. So Apaleo now calls our webhook to notify the app about this new reservation, and then we can use the get reservation details by ID to retrieve all the details for this reservation ID. And just a moment later, there is a mail inside my inbox. So here, hello Mr. Max Mustermann, thanks for your booking, we confirm your data, and so on. I've got an English mail here because when we look into the reservation, the booker I used has a preferred language of English, so we take this data to choose the language we want to send the mail in. So that was the automatic delivery, but as I said, there's also an on-demand mail processing, so we can look at that when we open the reservation. Then we can open here the guest mailings tab, and we see that there's already a confirmation sent to this address, of course without a comment because it was automatically sent, but we can send another one manually, for example by when we want to change the recipient, or if we want to send that in another language, or with an additional comment. So for example, we add a comment here. You can use the parking lot behind the house, and the mail is queued into the system. Again, we use the get reservation by ID call to get the reservation details, and just a moment later I should have a new mail in my inbox with a German mail, which also includes my custom comment. That concludes my little talk. I hope you found it interesting, and I wish you a nice day.
Thank you, Tim. This is actually a very simple yet very useful app. It is now widely used from our app store. By the way, Alex, do you use Webhooks API?
Yeah, of course, we do use a lot of webhooks at Limehome for any kind of, I would say, business case. Think about also the confirmation email that the guest will receive after creating a booking on any of the OTAs available. They will receive a confirmation email that we sent out, we trigger as soon as we receive the confirmation event webhook from Apaleo. Similar is what we do for the checkout. So as soon as we receive from Apaleo the automatic checkout event, then we will generate the invoice and we will deliver an email with the invoice and all the details to our guests.
But what about the check-in process? How do you make sure that when people create the reservation in one of your properties, that it's fully paid and that the credit card is valid? How do you handle all this payment thing?
Yeah, for the payment transaction, before check-in, we do always check the reservation balance, and we use the payment service provided by Apaleo. So requesting the payment for a specific reservation just before check-in, or at any time that the guest is contacting one of our customer success agents.
But do you use payment links as well?
Yeah, sometimes when guests have troubles or they're not able to use our web pages, or somehow the registration part or the payment part of our customer journey doesn't work, we ask them to send us the payment using a pay by link that we can easily generate using Apaleo.
Yeah, that's what I like about Apaleo payment services. There's so many different options how you can collect money and make payments. Either it's credit cards or payment links or terminal payments. And the cool thing is that those payment services are seamlessly integrated into the rest of the platform. So there's a very rich payment API that you can access as a developer. You can trigger payments. You can store credit card data, or you can trigger payment links, things like that. And for us, the user experience is very important. So we'd like to make sure that everything works seamlessly and in the best way possible. And the way how the payment services works is not a bunch of different integrations with different payment providers, but rather it's payment services that are integrated into the platform. But this is when everything goes well and you actually have a valid credit card, for example. But there is also a big problem with the fraud in this industry. And Alex, for example, how do you handle it at Limehome?
Yeah, currently what we do is to ask to all our guests a strong customer authentication. We ask them to validate during the check-in and also after the booking via OTAs their identity. Yeah, and talking about fraud, we have our next guest, Julien Demare, risk officer from Adyen.
This video is going to address fraud prevention in practice in the hotel industry. Hi guys, I'm Julien Demare, risk officer for adyen. In this video, I will cover the different types of fraud we have in the hotel industry, the specific hotel requirements, and the data fields we can use in this industry. Let's go through the two typical types of frauds. The first is payment fraud. It might be seen in different types of shape, such as hostile fraud. Is when someone is using a stolen or compromised card. Another way to see it can be friendly fraud. Is when someone is using his own card and calling his bank to have the money back. And a third type is card testing, when someone is using different cards in a small time frame. Aside of payment fraud, we have the no-shows. The no-shows is when someone is placing a booking with no intention of ever showing up. You might have two typical types of no-shows. The first one is the visa fraud. So it's when someone is, well, if we take the example of Europe, someone outside of Europe wants to move to Europe for a few days, weeks, or months. For this, you might need a visa, and to increase the probability to get a visa, you will have to join a proof of booking in your visa application, and this might lead you to generate no-shows. It has a big impact for the hotel industry in terms of revenue per available room, since hotels won't be able to charge at least the full length of the stay. Second type are the dirty bookings. Dirty bookings can be explained, well, a typical funny example is, well, imagine a small town where you have only 2 hotels. Well, one hotel might try artificially to book out his main competitor simply by placing a lot of bookings for a specific weekend in order to redirect genuine potential customer to his own hotel. The different type of requirements we have in the hotel industry. The first one is scalability. Why? Well, a typical big group like the Hilton group has more than 6,000 of properties. So it has to be scalable. We can't create one strategy per hotel. Why? Well, typical hotel group have a very diversified portfolio, meaning they have hotels in big cities, like capital cities, but also in countryside. So imagine your average booking in a New York City hotel will differ from an average booking in Wales in the UK. Second thing will be a luxury hotel versus a motel. Again, part of the very same group, but you won't have the same typical type of booking in a luxury hotel in New York City versus a 20 euros motel. Last one will be the size of the hotel. You want, in terms of strategy, there's different type of appetite from big hotels. The biggest hotel in the world has more than 7,000 rooms versus the appetite of a small hotel of 30 rooms, for example. Another hotel requirement is the time of payment. Most transactions will have an authorization at the time of booking. But for the actual charge, it will differ according to the transaction itself. It can be depending on the booking channel, could be depending on the policy of the hotel itself, but again, the time where the card is actually charged will differ. You can have 3 different times where the card could be charged. It can be done during the booking. During the booking, it's still the stage of a card not present transaction. The upside of doing it at the time of booking, first is to prevent risk of no-shows, because you actually capture the word charge, so you don't really care if the customer is showing up or not. You prevent any type of failed billing, again, because you receive the charge directly. Downsides are the risk of chargebacks. Again, it's because it's a card not present transaction, so it's a more risky type of payment. Another downside is that it's not customer friendly. A customer who is used to go often in hotels will be used to pay during the time of checkout. Another time where we can capture the charge is at the time of check-in. So upside will be to prevent chargebacks, because during the check-in you can make at the reception a chip and pin transaction, where the banks are liable in case of fraud, not the hotel. Another upside is that you prevent failed billing, if the customer shows up, of course, which leads us to the downsides. You have a risk of no-show. If your customer doesn't show up, well, you can't really ask your customer to pay on chip and pin, can you? It's still not very customer friendly. Again, someone who is used to go to hotels will again be used to pay during the checkout time. And during this time of COVID, we see hotels doing an online payment at the reception for social distancing. So when that's the case, you still have a risk of chargeback because it's an online transaction. Last potential time where you can capture the card is at the time of checkout. It's very customer friendly, it's a standard way of doing it. You have no risk of chargebacks if it's done through a chip and pin transaction. Downside will be risk of no-shows. If the customer didn't show up at the check-in time, you won't show up for the checkout. Risk of failed billing. And again, if it's an online capture at the time of checkout, you have still a risk of chargeback. Another specific requirement in the hotel industry are the different type of booking channels. Why is, well, actually, most booking from a hotel will come from different channels. They might have some bookings coming from their own platforms, their own websites, and here you, as a hotel manager, you receive all the data fields, so first name, last name, email address, billing information, you really receive everything. But ultimately, most of the transaction will come from channels such as booking.com. The issue here is that as a hotel owner, you will receive very few information. if you receive the first and last name and phone number, you're already quite lucky. A last thing are other type of OTAs, or online travel agencies. And another risk here is that you might have some type of fake online travel agencies. So imagine someone creating his own travel agencies, but then using his stolen cards on his own platform. So now let's go through the data fields. What are the typical data fields we can use for the hotel industry? First, in terms of being scalable, you might need to obtain or generate calculated fields. So what are those fields? Well, typically you might want the hotel average length of stay, the hotel average price per night, hotel average time between booking to check-in time. You might want the average distance between the IP address of the customer and the hotel address. And also, potentially, you might want to do this on a per channel. Why is that your typical customer on a direct platform, on the direct website of the hotel, might have a different type of behavior from a booking.com customer. So now in terms of standard hotel fields, we have everything here on the screen, typically the hotel name, the city where the hotel is in, the country, the room type also, is it a standard or luxe? An extra product. During the booking time, did the customer ask or selected, for example, to have champagne present in his home? Checking date and time, check out date on time, the price per night, membership status, the booking channel, cancellation policy, and also more standard fields such as email address, IP address, phone number, and card type, for example. Thank you for watching this video. Have fun working on this hackathon, and good luck.
Thank you, Julien. I'm really glad that adyen works on the fraud problem, which is very challenging in the hospitality industry. And I truly believe that the only way to solve it is with the technology. And yeah, talking about the technology, let's jump back to our DEVrupt hospitality page, and let's dive in into the project templates that we have prepared for you. So let's check it out, this serverless one, because I really like it, how easy it is to deploy into the AWS cloud, for example, with just one line of code. Alex, I know that you prepared this one, and this is a serverless. Why did you decide to make it serverless? Is there a specific reason for that?
Mainly because at Limehome, we use a lot serverless and infrastructure as a code. So serverless is a framework that a lot of our team members daily use. Plus, a lot of our microservice that we build, they're built on top of some Node.js framework. So I find a combination of serverless and Node.js an easy way to have a quick MVP or a proof of concept for in this case, for our hackathon.
Yeah, true. Node.js is very, very popular technology with a really huge community out there. We do have also some microservices that are written in Node.js and TypeScript, and I really like those templates. But let's check them out in more detail. For example, in the environment TS file, you can specify the Apaleo client ID and client secret. Those are the API credentials that you can get when you sign up and create your developer account. Then you just need to fill them in here and start the project. And as a result, it will make an API call to get the reservation by ID and put a JSON to the standard output. If you check it out here, for example, there's an API client for the booking API, and there is a service with the Apaleo client, and that's where the call happens. It's simple as that. Yeah, and then talking about Node.js, we have our next guest. Let's learn more about this. So welcome our next speaker, Luciano Mammino, cloud architect, full stack developer, and author of Node.js Design Patterns book.
Hello everyone, my name is Luciano and welcome to this talk called An Opinionated Introduction to Node.js. So, as I said, my name is Luciano and I am a cloud and full stack software engineer. You can find me online on Twitter, LinkedIn, also you can check out my website. For most of my career I've been a JavaScript and Node.js developer, and one of my biggest achievements has been being the co-author of this book called Node.js Design Patterns, which right now it's the 3rd edition, so it's been a journey of several years throughout different editions. And the goal of this book is basically to help JavaScript and Node.js developers to ramp up with their Node.js knowledge and be able to build very efficient and production-ready Node.js applications. Now, before we get started with this talk, I want to mention that you can get the slides by scanning this QR code or checking the link you see down there. And the reason why I like to share the slides is because you will find a number of links, and also there is a link to the code examples you can see there at the bottom. So get the slides so you can follow on and then check out the links after this talk. Okay, today we're going to talk about a little introduction to what Node.js actually is. Then we're going to explain the difference between blocking and asynchronous I/O. Finally, we're going to show how to deal with asynchronous I/O. And then at the end, I'm going to show you some interesting patterns that you can use to take advantage of asynchronous I/O. First of all, what is Node.js? Node.js is an open source cross-platform JavaScript runtime environment that executes JavaScript code outside the web browser. So basically, JavaScript traditionally has been the language that was created to actually run dynamic code in a web page. With Node.js, finally we managed to have a way to run the same language, JavaScript, but also in a different context. So the context that can be, for instance, a web server, so something that runs outside the context of a browser. And it was created in 2009 by Ryan Dahl, who actually wanted to explore this idea of, can I just use JavaScript to build, for instance, a simple network application, something that can do a TCP connection and be a server rather than a client. And after a while, in the same year, was launched NPM, which is the package manager for Node.js. And that helped the project to grow a lot because a lot of people started to create and share their own packages, and the ecosystem grew bigger and bigger. And very quickly, Node.js was so powerful and famous that even big companies started to use it. For instance, LinkedIn, Uber, PayPal, and Walmart, among many others. Now, it is important to mention that there are some interesting differences in when you run JavaScript in the browser compared to when you run it in Node.js. So for instance, in Node.js, you don't have a DOM, a document object model, so you cannot manipulate HTML natively. And there aren't many browser-specific APIs, for instance, I don't know, the Bluetooth API or the Fetch API, and many others. Now, there are projects that are trying to fill the gap and try to make some of these APIs available also to Node.js, but there is still quite a gap there. Another interesting thing is that Node.js is not as sandbox as the browser, because you know that the browser is a very sensitive application. You are running foreign code and you don't generally know what kind of code is running there, so that the amount of stuff that code should be able to do is very limited. For instance, if you open a web page, that web page is not able to read any file in your file system. Instead, with Node.js, you are actually creating your own application. You need to be more in control. You need to define business logic. And that's the reason why Node.js is actually able to access the file system. It can also interact with the networking layer. You can create TCP connection. You can send UDP packets. And it is even possible to have bindings to native libraries, for instance, written in C or C++. And with that, you could even do system calls directly to the operative system. So that's just to mention that Node.js it doesn't have the same sandboxing that you get when you run JavaScript in the browser. When would you use Node.js and JavaScript? In general, when you're building something for the web, for instance, a website, APIs, web servers, single page application, bots for Telegram or Twitter or things like that. You can also build command line applications and different command line tools. You can also build mobile application if you use tools like React Native, Ionic, or NativeScript. You can also build desktop application like Electron, and you can even build embedded or IoT using things like Espruino or Johnny 5. So you can see that the whole JavaScript ecosystem has been growing and growing over time and has been reaching out from what was the original domain of web pages. Now, there are cases where you might wonder, okay, but can I use JavaScript for everything? Are there cases when I actually don't want to use JavaScript? And of course there are. Like, JavaScript is not a silver bullet for everything. And for instance, if you don't like the asynchronous model, which we're going to discuss a little bit more in detail, probably JavaScript is not a language you're going to appreciate particularly. Probably it's going to be quite counterintuitive for you to use that model while writing your application. Another good reason not to use JavaScript is when you have very stringent constraints in terms of memory, when you want to be in control of how the memory is allocated and deallocated. So in that case, again, JavaScript might not be the best choice for you. Another very common use case is when you are doing a lot of CPU or GPU heavy type of computation, and this kind of computation tends to be much more taking much more time than you generally will take to do I/O. So if you have an application that is actually doing computation only, JavaScript is probably not going to be the best language and the best runtime for your application. And finally, if you want to create native application, and by that I mean compiled for a specific operative system, you don't want to carry on a specific runtime like Node.js, then again, probably you need to look somewhere else and use other technologies. Okay, let's talk now a little bit about async I/O, because this is one of the main distinctive features of both JavaScript and Node.js. So we say generally that in JavaScript and Node.js, every input and out operation, for instance, when we make an HTTP request, that operation is said to be non-blocking. Let's see what that means. But I want to show you what that means by actually starting from a language, for instance, like Java, that is actually blocking. So let's see if we try to do a request, an HTTP request in Java, what actually happens. This is a very simple snippet of code. What we are doing is essentially just doing an HTTP GET request to google.com. So essentially we want to read the HTML code of the homepage of Google. So when we run this code, what happens is that in the first line, we are creating a client instance, then we are defining a specific request, and then at this point, we actually execute that HTTP request. Now, what happens at this point is that Java is actually establishing a TCP connection and doing all the HTTP protocol to actually send the request and start to get a response. And while all of that is happening, our code, it's blocked there, and it's not going to progress until this code is actually going to complete to do what it's doing. This is why we say that this is blocking I/O. So there is an I/O operation. The code is not going to progress to the next line until that I/O operation is completed. Now, when that operation is completed, we have a response object, and in that response object, we can finally call this method called body.string, which again is another blocking operation, because what is happening here is that you got an HTTP response, but you still need to get all the body of that response, and that's a streaming, so it's another asynchronous operation, and in Java that's a blocking operation. So when we call dot to string, that's actually buffering all the output from the response and converting it to a string. When this operation completes, our code is going to continue, and the system out println is finally going to be executed. And in our output screen, we are actually going to see the entire HTML code for the Google homepage. And finally, after that, the request is completed. So we are just going to print request completed. You can see how the code has been executed in order. So we started from the first line and we continued until the last line. Every time there was an IO request, that line would then continue until that request was completed. Now, is this approach bad? Well, it actually depends. If your application is very IO heavy, then maybe this approach is not the best, because if you want to do many requests, of course you're going to be blocking every single time. And let's try to visualize this with a diagram. For instance, let's assume we want to make 3 consecutive requests. And what happens if you were to use something like Java is that you start the first request, that's going to be a blocking operation. When you complete, you can start the second operation. That's going to be another blocking operation, which is going to take some time. And then finally, we can start the third request, and that's going to take some time as well. So you can see how if we want to do 3 requests, they are kind of stacking one after the other. And that's, of course, increasing the time. There is a lot of wait time between requests. Of course, you can always use threads, and that's probably one of the most common things you will be doing in Java. If you have a situation like this, you will create 3 different threads, and you will just run every single request in its own thread. This way, you can actually parallelize making 3 different requests and therefore be a little bit faster. And in fact, you can see that here the requests are not stacking one after another. They are just running in parallel in their own threads. So the total amount of time that we allocate for this operation is actually much shorter. There is a problem though, that threads are complicated, or at least they are to me. And they are also expensive because, of course, you are allocating a thread at the operative system level. So if you want to do thousands of requests, it might not be the most lightweight approach to do parallelism. And there is still a lot of idle time per thread. What I mean by that is that inside every single thread, when you start the request and when you actually receive the response, the thread is still waiting idle for the IO operation to complete. But let's see how the async IO approach that we have in JavaScript, it is different from what we just seen from Java. So here we have exactly the same code. We want to do an HTTP request. We want to get the HTML code of the google.com page. And then we just want to print that in the standard output. So what happens here? The first line, as soon as we do client.get, that's actually starting a request. And this request is actually starting in the background. So what happens is that JavaScript is not blocking here, but it is actually continuing the execution. And the next logical line is going to be that console log statement that we see there. So in the standard output, we're immediately going to see request completed. But that's actually not true, because the request is still pending and doing stuff in the background. Is not really completed. Well, at some point, that request is going to complete. So at that point, this function is executed. And this function is something that is called generally callback function, which basically means I'm going to do an asynchronous IO operation. That operation is going to happen in the background. When that operation is complete, execute this function for me. So now that the HTTP request is complete, the callback function is invoked. And that callback function is going to receive 2 arguments. The first argument is generally an error, which is going to be either null in case of success or an actual error in case of failure. And then the actual result of the IO operation that we were trying to do. In this case, is going to be an HTTP response. So in this case, we can just say response.body, and that is going to allow us to print the HTML code of the Google homepage. Now you can already see that the code is not executed in order. And just to recap, basically what's happening is that the first line that gets executed is this client.get. Then we execute the first console log, which is just going to say request completed, even though it's not really completed yet. And finally, we are going to execute the callback, which is going to print the entire HTML body of the Google homepage. So there is a mental model that is slightly different from blocking I/O. With asynchronous I/O, you have to think like you are scheduling asynchronous work to happen in the background, and then eventually you will be notified when that piece of work has been done, or maybe there was an error. So you don't have to manage threads to get concurrency. But you probably also heard that JavaScript and Node.js are single-threaded runtime. So how does it happen that we can actually run multiple requests in the background without blocking? Let's try to describe again the example with 3 requests to understand a little bit better how with a single thread we can manage multiple asynchronous I/O operations. So let's say that we have one user thread, which is exactly the thread that is running the code that we have been writing. And let's imagine that code is trying to run 3 different HTTP requests. So what happens is that at the beginning of the code, what we do, we start the first request, and this request is scheduled and something that is called event loop is going to take care of actually running it in the background. Now the user thread can continue the execution and is going to schedule another request. Meanwhile, you can see that the event loop is progressing with the first request and is starting the second request. Then again, we start a third request from the user thread, and again the event loop, while it's progressing with request 1 and request 2, is going to also start request 3. And then the user thread doesn't have anything else to do, so it's just going to wait for one of these 3 requests to finish to actually do something with the response coming from that request. Now, at some point, request 1 is the first one to finish, so the event loop is going to notify the user thread that the response for request 1 is actually available, and the user thread can run some additional code to process that response. And then when that's finished, it doesn't have anything to do again, so it's just going to wait for another request to finish. This time, the request number 3 is going to be the fastest to complete, so again, the user thread can start to process the response, and then it's going to wait again until the request number 2 is going to finish as well. So you can see how with just one thread and the event loop, we are able to run 3 different requests in the background concurrently. And this, in my opinion, leads to simpler code for the user because you don't have to think in terms of thread. You are just thinking in terms, okay, I'm going to schedule something and be notified when that something actually happened. And the idle time, there is still some idle time, but that idle time is going to happen only in the user thread, only when you don't have anything else to do and you are only waiting for I/O to complete. Of course, this is an oversimplification. If you really want to understand how Node.js and the event loop and JavaScript actually work, this is an amazing talk that you have here on the slides. I really recommend to check it out if you want to understand a lot more in depth how the whole engine works and how things are scheduled and how the notify mechanism will actually work. Okay, now let's move to a slightly different topic. And let's try to see some examples on what are the most common ways that allow you to describe asynchronous I/O in Node.js. Let's start from an example. The idea is to have a fictional business case where, for instance, we might want to create a function that allows us to take a specific guest by ID, take the last reservation for that guest if there is any, and if that reservation is active, we want to delete it. Keep in mind that probably we're going to be using APIs or a database. So to access the guest, we probably need to do an asynchronous I/O operation. Then to get the details of a reservation, we still want to do an asynchronous I/O operation. And then to actually delete that reservation, this is probably going to be another asynchronous operation. So we have a sequence of asynchronous steps, and we have to figure out how we can describe this type of computation. So the most traditional approach is to use callbacks, which is the one we saw in our previous example. And the idea is that basically for every asynchronous call, what happens is that the last parameter of that asynchronous call is going to be the callback function. And we can see it here that for getGuest, we provide a callback function. For getReservation, we provide a callback function. And for deleteReservation, we also provide a callback function. So the idea again is that do some computation, and when that computation is completed, invoke the callback function for me so I can do something with the response of that asynchronous operation. Now you might notice that since we are doing asynchronous requests that are depending from each other, so one needs to start only after the previous one has completed, this code tends to kind of shift to the right side. And this is a common anti-pattern that is called callback L. And you can find a lot of funny memes about this on the internet if you look for it. To try to solve the problem of callback L, promises were created. And promises are an interesting abstraction that can actually help to simplify the code and can help to describe asynchronous operations. So the idea is that when we do an asynchronous call, something like this, rather than providing a callback that needs to be invoked after the asynchronous operation has completed, that asynchronous call itself is going to return an object. And this object is what we call a promise. So the idea is that a promise it can be used to actually track the duration of an asynchronous operation. So it's basically going to be able to notify you when that operation is completed, if that operation fails, or if that operation is still pending. And the way that you actually hook into a promise to do something when the computation is completed is by using this method called .then. So you receive an object, you call .then on it, and then you provide a callback inside of the .then. And basically what is going to happen is that when the promise is fulfilled, which means it's either rejected in case of error or resolved in case of success, that function is going to be executed, and with that function you can actually access to the result of the computation and do something with it. Now, in order to avoid again the same anti-pattern where your code is going to start to drift to the right side, when you have a chain of asynchronous operations, the promise abstraction allows you to chain a number of then, and that way we can basically keep adding operations at the bottom, and we don't have to nest functions one inside the other. So that leads to a little bit more readable code. Now, promises are still not perfect. For instance, here in this case, since we don't always want to delete the reservation, and sometimes, for instance, for a given guest, there might not even be a reservation. So basically here we have a part of computation that is asynchronous, but is also optional. It will depend by specific conditions that could happen or could not happen. So in this case, you can see that the code is a little bit awkward because we are still using the then, and then we need to check if there is actually a reservation, because if there isn't, we just need to return false. So this is just to show you that promise is an improvement over callback for sure, but there are still cases that are a little bit hard to express when you deal with promises. And async await is the next evolution from promises, and it's actually built on top of promises. So the idea is that you can have functions where you declare the function itself as async, which basically means inside this function I want to deal with asynchronous operations. And then when you have a promise, for instance here when we are calling getGuest or getReservation, you can decide to stop your execution until that promise is actually fulfilled. So for instance here in the first line we are saying guest needs to be initialized to the result of that promise. So when we are saying await in front of a promise, that whole expression is going to be resolved in the result of the promise rather than in the promise itself. So that way we are actually assigning the result of the asynchronous computation directly into guest. Now this is interesting because this leads to code that is a lot more readable and it looks more sequential than what we saw with callbacks and promises. And also you can see here where we are dealing with reservation again, that an if statement looks like a regular if statement, and we don't have to do special things to deal with them. So there are other advantages with async await. As I said, it's easier to read and reason about code because it looks a lot more sequential. It is easier to deal with conditionals, as we also showed, but there is also unified error handling. I didn't show this, but basically when you deal with callbacks and promises, the way you deal with errors is a little bit different. You cannot just throw errors and then catch them. With async await, actually the syntax has been unified, so you can actually throw errors, and even from an asynchronous operation, and that error will bubble up correctly and you'll be able to catch it. So that's another advantage for using async await. One of the important things is that you shouldn't try to understand async await before understanding callbacks and promises, because async await is actually relying a lot on both the previous abstractions. So if you don't understand them, you're probably going to have a misleading understanding of what async await actually does, and you'll end up writing code that doesn't actually behave in the way you would expect. So don't try to take a shortcut and learn async await before actually having mastered callbacks and promises. Now, these are not the only ways to handle asynchronous flows. There are also events, streams, async iterators, async generators. I'm not going to cover all of them, but if you're curious to find out more, click on these links and you will find some documentation that can help you out to understand these other concepts. Now I want to conclude this talk by showing you a few interesting asynchronous patterns that you can actually start to use in your code and take more and more advantage of the asynchronous paradigm. Now the most common pattern is to do sequential execution. So you have a number of asynchronous tasks that you want to run. For instance, you have a number of guests by ID and you want to delete their latest reservation. For some reason, let's assume that we want to do that operation in sequence. And now one simple way to do that using async await is just do a for loop over the array and just use a wait in front of the function. So by doing this, we are essentially, for every cycle of the loop, we are waiting for that asynchronous operation to complete before we move to the next cycle of the loop. Now there is a common pitfall here. So it's very common for people to use, when you have an array, to use for each. And if you try to apply this pattern with for each, it doesn't actually do what you would expect to do. For instance, here what we have is that the function that we are defining inside the for each gets executed very quickly for every element of the array, and for each is not awaiting every single call to that function. So essentially what happens is that you are creating 4 different promises, and these promises are started one after the other without waiting for the promises to complete. So this way you are actually ending up implementing a parallel execution rather than a sequential one. So this is a very common pitfall. Just be aware of this one. Now let's say we actually want to implement concurrent execution. We could have been using the for each as in the previous example, but you can also use map, because map can actually allow you to extrapolate the result of the asynchronous computation. And one common way that people generally do is to do promise all, and that's basically gonna wrap all the single promises, one for every guest, and then we are gonna wait the completion of all the 4 promises together. Now just be aware that promise.all is gonna stop in case of failure, but it's gonna stop as soon as one of the asynchronous computations is gonna fail. Is actually gonna return you a promise that is rejected. So it might not be the best approach when it could be okay for you to fail for one of the elements, but you still want to succeed the entire operation. When you actually want to do that, there is another approach that is called promise all settled, which is going to give you for every asynchronous computation a result that is going to represent the status of that specific computation. And you will have, in case of success, status fulfilled, and value is going to contain the actual value coming back from that asynchronous computation. In case of failure, you will have status rejected, and reason will contain the actual error that happened in that asynchronous computation. Now, another interesting pattern is that sometimes you want to do things concurrently, but you end up having many items to actually parallelize a computation on. For instance, here, let's assume we have hundreds of guests, and we want for all of them to delete their last reservation. Of course, you can use the patterns we saw before, but in this case, it is better to limit the amount of concurrency. For instance, in this case, I'm doing 2 guests at the time, and I'm never going to have more than 2 guests. So as soon as one guest has been completed, we can add another guest and keep processing a maximum of 2 guests concurrently in the background. Now, here I'm using a library that is called async, just to make it confusing. It's not the actual async keyword, but it's a library called async. And this library exposes you a bunch of asynchronous utility that you can use to implement different types of asynchronous flows. In reality, you could implement this yourself by using a queue, but I didn't want to spend a lot of time showing that. If you're curious, this is a topic that I explore in the book I mentioned at the beginning of the presentation. And now I want to show you the last pattern. This is actually an interesting one because I think it's not extremely common to see this pattern, but it's actually a very simple pattern to implement, and it can give you a decent boost in performance in cases where you have a lot of concurrent traffic to a web server. Before explaining the pattern, I want to show you what kind of use case we are trying to address here. So this is a very common use case. We have an HTTP server. This HTTP server is going to expose some functionality that is going to need the server to reach out to a database and ask for some data. So generally what happens is that you have a user. The user is going to do a request to the server. And in order to fulfill that request, the server needs to connect to the database, get some data, and then with that data is going to be able to respond to the user. Now, what happens very common is that as soon as you start to scale, you might have a bunch of concurrent users. So you have the first user, you start to do a request to the database, and while that request is in flight, you start to have other users doing the same request. So if you implemented this in a traditional way, where you are not trying to optimize the number of connections to the database and the number of queries, essentially you end up doing the same query to the database 3 times concurrently, 1 for every single user. And then you're going to start to receive the different answers to your query and return them to the users. Now, a slightly more optimized approach could be the following. You get a user doing the first request, and you try to keep track of which requests are in flight. So in this case, availability v1 units, you start to record that this is an operation that you are trying to get the data for right now. So at that point, the HTTP server can go to the database and wait for the database to answer. If other users are requesting the same information while we are already waiting for a response from a database, what we can do is just use, for instance, a promise to keep track of, okay, there is already a computation happening there. I'm just going to use the same promise to track that computation rather than starting new requests that will be effectively the same to the database. At some point, the database is going to respond, so we can resolve that promise and use that resolved promise to actually respond to all the users at the same time. So this is why it's called request batching, because the idea is effectively, if the same request keeps happening while I'm trying to fulfill that request, once that request is fulfilled, I can answer to all the users that were requesting that information at the same time, rather than starting independent computation for every single user. Of course, this optimization makes a lot of sense if you have a lot of concurrent users requesting the same data, and that data doesn't depend on the user. For instance, you're not fetching user-sensitive information like, I don't know, a credit card number that will be different for every single user. So this is more for information that will be the same for every single user. Now let's see how we can actually implement this pattern, and it's actually quite simple. So this is just a generic web server that what it's doing is checking if the URL is correct. If it's not, it's just gonna return a 404. If the URL is correct, it's actually gonna call a function that is responsible to get the data from the database, and then when that data is available, it's just gonna convert to JSON and send it back to the user. So this is super simple. The real implementation is inside this get available units from DB function. Now the first thing that we want to do is to define a variable that is called pending request, and this variable initially is set to null. But in this variable we will want to store a promise when there is a pending request to the database. So in our function, the first thing that we do is we actually check if that value is not null. And if it is not null, it's going to be a promise that we can just return to the calling code. And you can probably remember in the previous slide, we had an await. So the calling code is just going to wait for this computation to finish. Now, if this is the case that we don't have a previous request pending, we actually have to initialize the request. And we do that by calling, for instance, in this case, db.query. Let's assume this is a connector to a database. It's going to do a query. This is going to be another asynchronous operation. Now, be very careful here that we are not using the await keyword. So what is going to happen here is that pending request is going to be a promise and not the result of a promise. So that promise is something that initially is going to be pending, is still doing some work in the background, is not completed. And here we want to use another feature of promises that is called finally, and that feature allows us to say when that promise is completed, at that point clean up the reference to pending request. So this way we are actually resetting the promise, so all the concurrent users will receive a response, and then the next user that is going to do a request is going to actually trigger a new round trip to the database. So this way we can always keep fresh data and try to optimize only for users that are actually requesting the data at the same time. And finally, we return that promise. So even the first user requesting this operation is going to have a promise to await before it can receive the response. So this is basically it, the way you can implement this pattern. And if we want to do some benchmarks and take this number with a pinch of salt, because this is a super simple benchmark and there are many factors that will change the results. For instance, concurrency, how much time do you actually spend doing I/O. So you might get very different numbers, but generally if you have a decent amount of concurrency, with this approach you should be able to shave some time in responding to the users, and therefore you will achieve better throughput. So in my case, I got 50% better requests per second responded to the users. Now let's conclude this talk. And again, I'm going to give you my opinions about Node.js and take them as opinions. So Node.js is a great runtime for I/O-bound applications. It is also great for full stack web development because you can use JavaScript across the entire stack, front-end and back-end. Probably you can reuse a lot of the same business logic, models and whatnot, libraries. Also, the asynchronous model is great because it allows you to express concurrent computation in a very effective way without thinking about threads and without having to do complicated things to coordinate different threads. You still need to master callbacks, promises, and async await if you want to be effective, if you don't want to bump into weird situations where maybe you're doing a mistake and you don't realize until your code is actually running in production. So just be very careful that there is a little bit of a learning curve there and don't underestimate that learning curve. And finally, there are many patterns that can help you to keep your code clean, organized, and more performant. So also allocate some time for yourself to explore these patterns and learn more about how to take full advantage of asynchronous I/O. If you want to learn more, there are some links there that you can explore later on and have more resources to learn about JavaScript and Node.js. With that, this is the end of my talk. Thank you very much for listening. I hope it was informative. Feel free to connect with me on Twitter if you want to ask any question. And what else can I say? Enjoy the hackathon, and I'm really looking forward to see your projects. Bye.
Thank you, Luciano. Indeed, Node.js is a really great technology for full stack development. As a matter of fact, today we open sourced Apaleo Slackbot, which is also written in Node.js. So feel free to check this out on the GitHub, Apaleo/Slack, and feel free to contribute. Yeah, we are very excited about this event, and we welcome everyone in our Slack. If you need any help, look for pandas that we have. This is our advisors. They are here for you in case you need any help with the technical questions or about your project ideas. So I wish you luck and happy coding.
Good luck, guys.
Bye. Peace.